Hi guys, so we talked midpoint. Last thing I'm going to do is look at some examples. And so these will be a mixture probably of all our techniques. We'll probably use some graphing techniques here, but also use a lot of formula stuff too. So let's get to it. So we have to find the midpoint between these two line segment with these endpoints. So -1, 2 and 3, -6. So immediately we're going to go into our midpoint formula here probably. So this will be our first point. This will be our second point, which makes this x1 and y1, and this x2 and y2. So to recall our formula, the x value for a midpoint, the y value for a midpoint, because it is a coordinate point, so it has to have an x and y value, is found by taking the x's and averaging them together, meaning them add them together and then divide by 2. And our y coordinate will be found by adding the y numbers together and then dividing by 2, because that's how we average the y's. And so on the x calculation, looks like we're going to have -1 and 3. So we have -1 plus 3. Divide that by 2 to find the average. And then for our y's, we'll have 2 and -6. And so that'll be 2 minus 6 over 2. Now, if you note here, the formula has a plus. That has a minus because of the negative on the 6 will override the positive. We know that a positive and negative make a negative. That's why it ends up being a minus in this case. So -1 plus 3 is just going to give us 2. And then 2 minus 6 will give us -4 over 2. Now, we don't have to make these decimals, but these are actually going to be reducible, because we know 2 over 2 is 1, -4 over 2 is -2, and so our midpoint is going to be 1, -2. All right, so here we have, well, we're going to deal with some decimals here, but that doesn't change what we're going to do. Let's do some labeling first, just so we keep everything straight. So this will be x1, y1. This will be x2, y2. And so when we go into our formula, the x value of our midpoint, the y coordinate of our midpoint, is found by adding the x's together, x1 plus x2, and then y1 plus y2. Okay, so here we have 6.4, and we'll subtract off at 10.7. For the y's, we'll have 3, and then we'll add 4 to it, drop it over 2. Okay, so we can grab a calculator, or maybe we can try to do this in our head. This looks like it's going to be -4.3 over 2. So 3 plus 4 is 7 over 2. Now, because part of this is in decimals, we probably want to express the whole thing in terms of decimals. So let's go ahead and grab our calculator here. Okay, and so let's go ahead and double check our first calculation, because we want to make sure we're playing it safe. So we had 6.4 subtract 10.7. It is indeed -4.3. Let's divide that guy by 2. And so the x coordinate is going to be, for our midpoint, will be -2.15. 7 divided by 2 is 3.5, so let's keep that there. So our midpoint in this case, our coordinates of the midpoint, I should say, are going to be x is -2.15 and y is 3.5. Right? So those are pretty straightforward, just applying the midpoint formula to get the value that we need. These problems are going to be a little bit different. So here, if you look carefully, they don't actually want us just to plug this blindly into the distance formula necessarily, because they're not asking for the midpoint. They're actually telling us the midpoint. They're saying m is the midpoint of AB, and then m is going to be 1, 0. They're saying one of the endpoints, A, is 2.3, and we actually want to find B. And so let's get a little visual what's going on here. So we have this segment that starts with A. So that's A. Its coordinates are -2, 3. And then this line continues, and this is just a representation, mind you, to the middle, M, as in the midpoint. And they actually know the coordinates here. This will be 1, 0. Getting that from right there. And the line continues in the direction for B. And then we just don't really know what B is, but they want us to find B. they want the value of b. So for this one, I think I'm actually going to turn to the graph to help us understand what's going on. So let's take a second. Let's actually transfer these values to the graph. So a is going to be -2, 3. Okay. B is going to be 1, 0. Okay, and they want us to find C. I'm sorry, we want to find B, the other point. So we have A connects to, let's make that M actually. Okay. And this is going to travel to some B value down here-ish. Okay. So I think we probably could use a formula to do this, but since I have a graph here and since we know that we can count an indirect distance, I think what I want to do instead is figure out how just to get to M from A. To get from M to A, it seems like we got to do a couple things. First, we have to go over, looks like 3 values. Then we have to go down 3 values. And so the question is, if I continue this pattern and I want to get to the next point, well, all I really have to do is just do this again. And so if I go over another 1, 2, 3, and then down 1, 2, 3, which I know I'm off the grid, I should get to that B value. Well, if we look at the X values, from 2 to 1 is at +3. And so if I go another 3, I should end up at 4. Okay? So it was 3 from -2 that got me to 1. 3 more from 1 gets me to 4. And I can do the same thing in the y direction. So we start at -3 and go down 3, we get a 0. We go down another 3 and we should end up at -3. And so our b value is actually going to be 4, -3, which fits more or less with our grid is. It looks like it was a little cut off. My fault about that, guys. But that's going to be our b value. Looking back up here, we can kind of replicate that work. We can look at that this kind of same way. If I go from -2 to 1, that's a total change of +3. And so if I want to get to the end again, to my end point, I'll do the same thing, +3. 1 plus 3 is going to give me 4. In the y direction, we went from 3 to 0, which is a total change of -3. And so if I want to get to my endpoint, since it's got to be in the exact middle, we'll do the same thing, subtract another 3, end up at -3. And so even without a formula, if we just kind of understand that the midpoint is the middle and it's got to be equally spaced from both ends, we don't need a formula to calculate this. We can actually just count, and I think that's probably good enough. Here we have another problem that's very, very similar. So we're given the midpoints, excuse me, and we're giving it an endpoint. So we have A is going to be the endpoint. So again, trying to get a visual. A is going to be 2, 3. That's going to go to some midpoint in the middle, which is going to be 4.5, 6. And we have to try to figure out what B is. For this one, I think what I want to do, since we already kind of talked about how to count and accomplish a problem like this, I think what I want to do is go ahead and use a formula, because I think we can do that too. So if we recall the formula for midpoint, if I want the x value of the midpoint, that's going to be the same as taking the x's and adding them together, then dividing by 2. And if I want the y value of the midpoint, that's going to be the same as taking the y values together, adding them, and dividing by 2. Now the reason this is important is because this tells me I can actually separate my formula. And so the x value of the midpoint can be set as an equation with just the x numbers, x1 plus x2 over 2. And we do the same thing for y. So the y value of the midpoint is the same as y1 plus y2 all over 2. And so if I go into my equation, this little representation above, I can start yanking values. I do actually know the x value of my midpoint. It's going to be 4.5. I do know the first x value of my midpoint is going to be 2. Now I don't know the second one, but this is a solvable equation. I can just simply solve this from here. Okay? I multiply 2 on both sides to try to get rid of my 2's. That'll leave me with 9. So 9 is the same as 2 plus x, my second x value. Well, then if I subtract 2 on both sides, I get 7. And so that tells me this number right here is going to be 7. I can do the same thing for my y's. I do know the y value of my midpoint. It's going to be 6. I do know the first y value, which is going to be 3. I don't know the second, but that gives me enough to actually solve this like an algebraic equation. I can multiply 2 on both sides, get 12. Then I can subtract 3 on both sides to get rid of that 3, which means my y2 value has got to be 9. Okay. Now, this is a little bit more studious, I think, than the first one, but certainly an equally good methodology. So I could use either counting and a graph to help me understand where to get that extra endpoint, or I could plug it into a formula. Again, a little more complicated, but gets an answer just as well. Certainly, if we did this work and repeated this work on the graph, we should find that it all backs up. Okay. So what I mean, let's kind of shrink this a little bit. Okay. What I mean is this. If we take our A point, which is going to be 2 comma 3, and we take our midpoint value, which would be 4.5, 6. 4.5, 1, 2. Okay. And we just use a counting technique. This is going to go over 1, 2, let's use a different color actually. This will go over 1, 2.5, and then up 1, 2, 3. And so we just double that and go over 1, 2.5, then up 3. That should land right here, and if we count that out, we have 1, 2, 3, 4, 5, 6, 7, then up 1, 2, 3, 4, 5, 6, 7, 8, 9. And that should be our B, and we have that at 7 comma 9, which is precisely what we calculated it would be using the slope formula itself. And so again, it doesn't matter the technique, both are equally good. There are merits to using both. Personally, I prefer the counting techniques. I think it's a little more intuitive, but that's up to you guys. It doesn't really matter to me what you use as long as you're using something to get that endpoint. Okay, and so again, midpoint is just another way to find the bisection point. We can count using a graph, or we have a midpoint formula. This example is using midpoint formula, but the graphing counting technique is sometimes actually more useful for more complicated problems. So that's slope for parallel and perpendicular lines, and also for midpoint. So I hope these helped. Now it's time to put them to work.